Designing EMI shielding that keeps pace with modern electronics is getting increasingly complex. As devices shrink and operating frequencies rise, shielding solutions must strike a careful balance between conductivity, weight, durability, and seamless integration with existing components. Conductive coatings have emerged as a leading solution, offering lightweight and conformal coverage that delivers reliable EMI suppression across a wide range of frequencies and form factors. When combined with woven wire mesh, their effectiveness is taken a step further, enabling a more precise, resilient, and customizable shielding strategy. Electromagnetic interference continues to pose major challenges in today's high-speed, high-density electronic environments. As devices grow more compact and powerful, traditional shielding methods, such as metal enclosures, often struggle to meet the demands of modern performance without introducing trade-offs in size, weight, or design flexibility. This is where conductive coatings come into play. Applied as thin films or sprayed-on layers, these coatings provide an effective path to grounding and attenuation without adding bulk or restricting airflow. By using materials such as copper, nickel, or aluminum, conductive coatings create a low-impedance surface that reflects or absorbs incoming EMI, protecting internal components from both radiated and conducted interference. What makes coatings particularly valuable is their versatility. They can conform to complex shapes, bond to various surfaces, and support scalable manufacturing. This makes them ideal for industries like aerospace, telecommunications, medical devices, and automotive electronics. But while conductive coatings offer excellent surface level protection, they're often most effective when paired with structural support that enhances their conductivity, durability, and overall shielding capacity. That's where woven wire mesh begins to elevate the conversation. While conductive coatings offer a lightweight and adaptable shielding solution for EMI, they face challenges when it comes to mechanical strength, long-term durability, and maintaining consistent conductivity under stress. That's where woven wire mesh steps in, not just as a replacement, but as a powerful complement. When integrated beneath or alongside a conductive coating, woven wire mesh provides a continuous conductive path that helps maintain shielding effectiveness even as the coating wears, cracks, or experiences vibration. The mesh acts as a reinforcement layer, preserving EMI integrity in rugged or high-performance environments. Wire mesh also supports grounding continuity, ensuring that any charge or noise captured by the coating has a reliable path to discharge. This is definitely important in mission-critical applications where uninterrupted shielding can mean the difference between performance and failure. And from a manufacturing standpoint, mesh-supported coatings offer greater process control. The mesh structure allows for a more uniform coating application, reduces the risk of hotspots or gaps, and adds form stability to flexible or thin-walled components. So in short, combining the flexibility of conductive coatings with the strength and reliability of woven wire mesh creates a smarter shielding solution, and one that adapts to today's evolving EMI shielding challenges without compromising on form or function. So as modern electronics continue to shrink and speed up, high-performance shielding is greater than ever. Conductive coatings offer a unique blend of properties that make them well-suited for today's compact dynamic systems. The biggest advantage? Form-fitting flexibility. Conductive coatings can be sprayed, painted, or printed directly onto complex geometry. This makes them ideal for shielding irregular enclosures, tight spaces, or layered designs. Unlike rigid metal housings, coatings conform to the exact contours of your device, eliminating the gaps that could let interference leak in or out. Coatings also shine when it comes to weight and space savings. In applications where every gram and millimeter counts, such as aerospace, defense, and mobile electronics, coatings help engineers meet strict design constraints without compromising EMI performance. Additionally, modern coatings offer material versatility. Engineers can tailor the conductivity by selecting from a range of base materials and binders. This customization ensures that each coating delivers the right shielding level for its specific frequency range or environmental exposure. And when reinforced with woven wire mesh, conductive coatings gain structural integrity and electrical reliability. This allows them to perform in more rugged environments while extending their functional lifespan. Thanks so much for watching. If you have any questions, click our Talk to Us button to get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things WS Tyler. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.